Hello, everyone. My name is Tolani Ajayi. I am the project manager for assignment 6, and this is group 3. My team members are Pelumi, Ash, Fariha, Gilbert, and Quill, and this assignment is on project network. Executive summary of the assignments: a simplified network of the WBS and Gantt charts, which we developed in earlier assignments, was used in creating a generalized set of activities instead of individual work packages. And the expected time and variances of these activities were determined as well. The predecessors of these activities were also assigned, and the critical path for the project was also determined and is displayed in this presentation. A background on scheduling: this is the conversion of project planning into an operating timetable, which is used to monitor and control project activities, and it is based on the WBS, and it illustrates critical activities which can't be delayed, as well as Slack activities which can be delayed. Networking techniques used in scheduling are the program, evaluation, and review technique, critical path method, network representation, and construction of activity on node networks. Methodology: 38 activities were highlighted from the WBS and the Gantt charts. Each activity was given an optimistic time, likely time, pessimistic time, and based off of these times that were given, we're able to calculate the expected time and the variances. We were able to calculate this using these formulas for expected time and variances. And we were also able to determine the predecessors for each activity, and this helped us to further find the earliest start time, earliest finish time, latest start time, as well as the latest finish time for each activity. Moving on to the results. The network table that was developed as a result of all the methodology is seen here. We have a total of 38 activities ranging from the planning and specifications for the entire project to the specifications for each system, ranging from the hull system to the anchor system to the crane system to the propulsion system to the freshwater system to the sanitation system to the electrical and then the navigation system. So each system precedes each other except for the specifications of each systems, which have a predecessor of the planning and specifications for the entire system. And optimistic time for each of them was assigned, as well as the likely time and the pessimistic time. And based off of these times assigned, we're able to find the expected time and the variance, which is used in determining our slack and then determining our critical time, as we'll see moving on into the presentation. So in order to determine which activity precedes what activity, we followed a simple format of moving from specifications to the procurements to the construction/installation of different parts of these systems, and then to the testing of these systems. And this followed suit for each major system of our model. And this helped us to kind of create a simplified networking model for this assignment. And a few activities preceded each other, which we would see in our network diagram. So this is a completion of the network table, which ends at C trial. This C trial relies on the testing of every system in our network. As we can see here, every testing leads to the C trial. So this is the first half of the network model, which, as you can see at the bottom left, a quick representation of what each node represents. So in the center represents the activity. The top left, which is the ES, is our earliest start time. EF at the top right is our earliest finish time. LS at the bottom left is our um, latest start time, and LF at the bottom right is our latest finish time. And we can see that for each node, starting from the planning and specification, which starts at 0, moving on to 5.17, goes into each system specification, which has a different range of earliest start time to earliest finish time, moving on to the procurement of the systems and installations. So each of them follow each other without any um, reliance on any other system. And then moving further to the next part of the network model, we can see the electrical system moving into the freshwater testing system, freshwater testing node, to the sanitation system testing, and to the lighting system installation and testing. And then the rest of the system, the rest of the network model moves into the C trial after the testing is done. And we were able to determine the earliest start time, earliest finish time, latest start time, and latest finish time using our expected time that we calculated earlier. And we can see it represented here. And the whole network model ends after the C trial. So this is the general representation of the entire system network model. And moving on to our Slack table. So the Slack basically represents the delay that an activity could have until it becomes critical. So a slack of zero, if a slack of zero indicates that there shouldn't be any delay in an activity before it is seen as critical. So in the case of the whole system, as seen here, there is no zero slack. And for the other parts of this, other activities in the network model, we can see slack ranging from 19, 23, 12, and different values. And based off of this, we are able to conclude that the whole system is the most critical part of our vessel, and the construction of the hull is has to be done within the set time that we assign to it. If not, it is becomes critical, and the delay is, isn't what we are hoping for. And so continuation leads down all the way to sea trial. So we are hoping to do sea trial within a specified time, which cannot be delayed. So every other system activity has to be done before the set time for our sea trial. So we can't move the time for sea trial. If not, it becomes critical. So that's the point of the slack. And this slack is calculated using the formula of the difference between the latest start time and the earliest start time. And based off of this, we are able to get our critical path, which, as I said earlier, is our whole system, which moves from the planning and specifications to the hull and deck system specifications, procurement of the hull system, resources, hull and deck and rudder construction, mooring component installation, safety and inspection component installation, all system testing, and this sea trial. And then this leads to the end of the network model. And our critical time is 50.85 days. So yes, this is our critical path, and um, that really concludes the network model. So thank you for listening to this presentation. God bless.